Okay, so now we know how to get quite a few exact values in the first quadrant. So things like 0, 30, 45, 60, and 90. But sometimes you'll be given angles that are greater than 90 degrees, so obtuse angles, just things outside of the first quadrant. And you have to use a couple of things that you've already learnt to do this. But one thing you have to realize is, say my angle here, theta, goes, somewhere more than 90, goes out here. Well, there's going to be this angle here, alpha, which is going to make a similar triangle with something in the first quadrant. If I were to draw that in there. So say I had my unit circle coming around. Just going to draw the top half as best I can. Well, alpha here is going to be, if I think about, say cosine and sine, well, I know sine is the y value, right? So the value that, sine of theta, when we go all the way around here, is just going to be the same as sine of alpha, isn't it? Because the y value that those points on the unit circle make are the same. And you might realize with cos, well, cos was just the x value, right? So if I look at cos of theta, well, it's going to be kind of similar to cos of alpha, right? If I just had alpha and I look here, well, cos of alpha is there to there, right? The x value. And so with actual theta, it's the same distance from the origin, but it's in the negative direction. So cos of theta is just minus cos of alpha when we're in that second quadrant. Now, there are really similar rules, and you follow the same logic for looking at the other quadrants. But as in one of the earlier videos, I would suggest you just use some memory device to remember where things are positive and negative. So in the first quadrant, if you think about this being x and this being y, in the first quadrant, everything's positive, right? Cos and sine, the x values, the y values, they're always going to be positive. And cos with tan, it's just a fraction made up of sine over cos. It's also always going to be positive. Now we look in that second quadrant, we realized last slide that cos becomes negative, right? And so then tan will also become negative. So because even though sine was just the same and it was positive, if you've got a negative in a fraction, if you've got positive divided by a negative, you're going to get a negative. So we know that just sine in the second quadrant is positive, and the same logic follows around. So in the third quadrant, you've got just tan being positive, and in the fourth quadrant, you've got just cos being positive. You can kind of follow that logic through in your head if it doesn't quite make sense, and just really make sure it makes sense for you. But the easy way to remember it is just come up with a mnemonic device, as I suggested earlier, and we talk about the cast rule, right? Because if you read it like this, it spells out the word cast. So we're going to use that to do a couple of examples. We're just going to find for each one of them a different trig ratio. So I'll show you how it works. So here we want to get sine of theta. Now, what we need to do is, like with when we're in the second quadrant, we need to find that angle that your value here makes with the x-axis. So I know if that whole way around is 240 and just halfway is 180, if I added 60 on, I'd get to 240, wouldn't I? So that angle in there must be 60. So there must be some similar triangle, first quadrant. After this one, I'm going to stop drawing these similar triangles, but just to demonstrate here what we're doing. We've got 60, 60. So whatever the point is there and the point is there, you're going to have very similar values, right? So if I know sine of 60, well, I can then work out sine of 240. So if I think about my cast rule, I got C-A-S-T. In that third quadrant, only tan is positive. So sine of 240 is going to be negative sine of 60. Because we're not in its quadrant, or we're not in the all quadrant. Now sine of 60, I would just draw my little special triangle that I've done so many times I've now memorized. It looks like this. So what? Sine of 60, it's opposite over hypotenuse. So it'd be root 3 on 2 because we're in the third quadrant. It's negative root 3 on 2, if that makes sense. Now we look at cos. Well, cos of 135. So what angle is going to make it up here? What angle does it make with the x-axis? Well, it's 45, right? if you added on 45, you'd get to 180. So cos of, so if we think about it, cos of 135 in terms of its first quadrant kind of reference angle, well, we're in the second quadrant where only sine is positive, so we've got negative cos 45. It's going to be negative whatever cos of 45 is. And actually, a while ago, we used this triangle to get the cos of 45 is 1 over 2. So I'm going to write it as it must be, what's the negative of that? So it's negative 1 over 2. Again, we're just using one of these special triangles, one that looks like this, 1 root 2, 45. Cool. Tan theta. So here we're again in the second quadrant. That's where sine's positive. So tan of 150 is going to be negative of whatever that reference angle it makes with the x-axis is. So that is 30 to make up 180. So it's negative tan of 30. Luckily, I've already drawn my little special triangle here. So in there's 30. So tan is opposite over adjacent. So it's 1 on root 3. So it's negative 1 on root 3. Now you can rationalize those denominators and stuff, but you've got the answer there. And there we have it. Now, if we just do a couple of ones with radians, I'll just do them a bit quicker this time, the kind of process that I'd probably actually follow. So with this, I think about, okay, sine of pi on 4. Well, I know that's half of pi on 2, so it's 45 degrees. That's pi on 4. And sine, well, we're all positive there. Now, 45 degrees. I had my special triangle over here. Oh, it's gone now, but that's okay. So I've just got 1 root 2, 45 or pi on 4. So opposite over hypotenuse, 1 over root 2. It's going to be positive because it's in the first quadrant. 1 over root 2 is my answer. All right, now we've got tan of negative pi on 6. Again, I just kind of draw myself a little set of axes. Don't mind about that bit. And I just draw it in. So negative pi on 6. Well, I happen to know I've done enough of these to remember that pi on 6 is 30 degrees. So it looks something like that. And it's going clockwise because it's negative. But you could always do a conversion if you didn't remember that. So tan of 30, using my special triangle, 1, 2, root 3, 30 up here, pi on 6 as it happens. What, opposite over adjacent, 1 over 3. So we got, now it's in that quadrant, right? That's the C quadrant, C-A-S-T. So it's going to be negative, let's just rewrite that equal sign, negative 1 over 3. Cos of minus pi on 3. Minus pi on 3, so that is 60 degrees down here, minus pi on 3. Do that conversion again. If you didn't remember what pi on 3 is, if that didn't just pop into your head like it does once you've done 1,000 of these. What are in? We're in the cos thing, right? So AST. So it's going to be positive cos of pi on 3. Pi on 3 is the same as 60 degrees. So it's just down there in my special triangle. So cos is adjacent over hypotenuse. So it's a half and it's positive in the fourth quadrant. It's just 1/2. And there we have our answers. Okay, let's leave it there. Thanks.